Here we are, doing the last lesson in the trig unit. Now, I thought it'd be a good idea just to include a really quick warm-up that we can do before we get to it. So a couple questions that we haven't maybe looked at for a little while. And the first one is writing this equation of a sinusoidal function that has a period of 3 pi, is shifted down 2 units, and has a reflection in the x-axis and an amplitude of 4. Well, let's go ahead and tackle that one. So I'm just going to remind you that period is actually 2 pi over b. So if you solve for b, you're going to get that b is 2 pi over the period. So now they're telling us the period is 3 pi. So what we're going to do is we're going to just pop it into this equation here. And we're going to go 2 pi divided by 3 pi. And you're going to get a b value of 2/3. What else do we see here? We got a reflection in the x-axis, so we know that we're going to be taking our sine function and we're going to be applying a negative in front of it to get the reflection. So we did that part. Amplitude of 4 means that we're going to have a 4 in front of here, so that's our a value. And we got our b value, and it shifted down 2 units, so that's a vertical shift. And that's going to be -2. So we got -4 sine. Now remember, it's bx. So b is 2/3 times x. And then if there's any vertical shift, that's outside. So there's our answer for A. There it is, maybe written a little bit nicer. Now for part B, it's the same thing, but we're going to have a phase shift, which is a horizontal shift. I'm just reminding you of pi units. So that means that in the brackets here, we're going to go subtract pi. So now here's exactly the same thing. We just subtracted the pi out. Just keep in mind that this first thing is actually wrong. Okay, so that's an x as, and this is wrong. If you do it this way, remember, you have to pull out the b term. So what you need is you need to throw some brackets around the x minus pi so that the b term has been pulled out. And that's probably the trickiest part of that particular question there. Now, I'm going to just switch back to my first page here. For part C, this is a question from an older unit, which we might as well do. Now, we're taking our original graph, y equals 3 to the x, which is a power function. Now, just a reminder, those ones go through the y-intercept of 1, and they sort of look like this, and we got a vertical, we got a rather horizontal asymptote over here at y equals 0. I'm going crazy. Y equals 0, and this is the point 1 for y. And if you want to grab one more point, if you plug in x equals 1, you get a y value of 3, so we can go ahead and label this as 3, 2, 1, perfect. So that's the original function. Now what we're doing here is we are flipping it over the x-axis, right? So you have a negative sign here. That's going to flip it over the x-axis, and then we're shifting up 1 unit. Now don't forget that that horizontal asymptote at y equals 0 is going to experience all of those same transformations. Now, the only one that matters for the asymptote is this one. So your new asymptote is going to be y equals 1. So let's see if I can just kind of sketch this on here. We're going to go and throw our new asymptote right here. So there's y equals 1. Okay, now remember, this thing's going to flip over the x-axis. So what we can do is we can transpose these points, 1, 2, 3, and then we'll shift them all up 1 unit. So this one here would go over to -1, but then it shifts up a unit, so now it's at 0. This one here at 1, 3 would flip over and be 1, -3, and shift up 1 unit like that. And now the shape is going to be opening in this direction. And then don't forget to go and hug that asymptote like that. So there is the answer for part C. That would be a 2 or 3 mark question on the exam. It's generally 1 mark per transformation, and then they might give you a mark for just the general shape of the graph. So I'm thinking 3 marks possibly. Part D. Now this is, in this unit, a sine question, sinusoidal question. So just a reminder, you can pull all the values out that you need. So the amplitude is -1. Now my b value is 2. Now as soon as you know your b value, don't forget to go grab the period right away. So period is 2 pi divided by b. So you're going to get 2 pi divided by 2. And you have a period of pi. So this means we're going to see our regular sine curve happening in pi units. So that 1 full cycle is going to happen in pi units instead of 2 pi. We also have a vertical shift here of -1. So I'm going to go ahead and get my sketch right away. Now I'm not drawing horribly straight. So remember the way I like to do it. So I like to sketch it and do the amplitude and flip it at the same time. So normally we would be going like this, and there would be our sine curve. Now I'm going to just quickly sketch it out here. So regularly our sine curve would look like that. Now I'll switch colors here. Let's go to red. So we're going to go ahead and flip it. Okay, so because of the negative sign, it's going to flip. Anything on the x-axis is going to stay there. So this point is just going to go down here, and this point is just going to go up here. So now we can go ahead and draw a smooth curve through there. Do your best. Now, label it. So we know that one full cycle happens in pi units. So that's pi. Half of that is pi over 2. Half of that again means that this point is pi over 4. When you go pi over 4 plus pi over 2, that's going to give you this point at 3/4 of the way. This is going to be 3 pi over 8. Now, if you need to pause and do that on paper, go for it. But there it is. So there is our basic shape. If you do it my way, you're never going to have to muck around with the units. They're always going to take care of themselves, which is really nice. That's probably the hardest part of doing these questions. The last thing we need to do, second last thing, we didn't label it. So this is 1 and -1. And then we're going to do the vertical shift of 1 unit down. So we're going to extend this, and we're going to say, okay, here's -2. And we're going to shift all these points down. So I'm going to switch to a different color for our final graph. Here we go. So this one goes down a unit. This one goes down a unit. This one here goes down a unit. This one here goes down a unit. And this one here goes down a unit. And then just draw sort of a smooth curve through those black points. There we go, not bad. So there it is, the final answer for D. There you go. If you want to skip through this, maybe I'll throw a timestamp in the description. We are now ready to start doing the rest of the problems that we have here. So it's applications of trig functions. Basically, these actually have massive applications in real life. Lots of things look like sinusoidal waves. So now this one here is something I grabbed from the exam. So I might skip it for now. It's more just meant for review in class, and we already did the questions from before. I'm definitely going to skip 42. You can certainly message me if you need help for that one. But you know what? Maybe we should do this one just as practice before we get to the actual material for 6.7. So we're going to draw a sine curve. Now we got an amplitude of 2. A vertical translation, so that's the same thing as a vertical shift of 3 units down. So we'll just go vertical shift -3. And a period, so that's nice. They're giving us the period, not the b value, the period. So this means that we're going to expect, determine an equation for sine. Okay, so we are going to expect 1 sine in pi over 4 units. Now, all they want is the equation. Okay, so we're not sketching it. We're just giving them the equation. So we pulled out the information, and we just need to write it out. So the a value is 2. So we can go 2 sine. Now, we know period. The equation needs the b value. So just remember that b is 2 pi over the period. So when we go 2 pi divided by pi over 4, what are we going to get here? Just do the reciprocal. So you get 2 pi times 4 over pi. The pi's are going to cancel out, right, when you cross reduce. And you're going to get a b value of 2 times 4, 8. So that's what you're going to throw here. I'm going to just open up another bracket and write 8. Now there is no c term, right? So there is no horizontal translation. So we can just write 8x. And then plus d. Well, the vertical shift was 3 units down, so we go subtract 3. So there you have it for 2 marks. I do believe, I remember this one from the exam, the 8 is worth 1 mark, and then I think it was half a mark for the amplitude, and then the vertical shift down. Now determine the range. So generally, the range of our sine function is -1 to 1. So if we think of what happens to an xy point on our original function, and we do these transformations, well, let's see. We know that the b value is going to affect the x values, right? Now, this is back to transformation. So we know that we multiply by the reciprocal of whatever the b value is. So we're going to be going 1 over 8 times x. The amplitude affects the y values as before, and this also affects the y values. So basically, we have 2 times the y values, subtract 3. Now, they only want the range. Okay, so the range is -1 to 1. The range are the y values, so this is the only transformation I'm interested in. So when I take my -1, multiply it by 2, I get -2. Subtract 3, I get -5. And when I take my 1, multiply it by 2, I get 2. Subtract 3, gives me -1. Make sure that it's smallest to biggest. Sometimes that changes, but there's the range of the new function. Perfect. Now we're actually ready to go ahead and start the unit. Yeah, not going to do it. I'm done doing review. Let's do the unit. So this is the first question I have here. Now, they are a bit wordy. You don't always get one, but you generally get something. Okay, sometimes it's a big question, sometimes it's a medium one. So it says a large wheel has a diameter of 6. So right away, I would go ahead and sketch it, diameter of 6, which means that we have a radius of 3 units, which would be useful to know. So keep in mind that means that from the center all the way to any point on the circumference, that's going to be 3 units. What do we got? A point is marked at the top of the wheel, so we're going to start here. And the wheel rotates once every 20 seconds. So that means that we're going to get one full cycle. So say it's a sine curve. We get one full cycle every 20 seconds. So is that the period or is that the b value? And the answer is that's going to be the period. So the period is 20 seconds. Remember, period is how long it takes for one full cycle. So if I start here, 20 seconds later, I've done one full cycle, so that's going to be my period. So it says, sketch the situation for 2 full rotations. Well, we can do that. That's no problem. So let's go ahead and do that. Perfect. So I'm going to go ahead and use a sine function. So right here when we start, this is going to be a little bit different than what we're used to. So here's time, and it's going to be in seconds. And this axis is going to be my height. So that's going to be one of the differences. If they ask for a sketch, you're going to have to label it with what it means in the real world. And right at the beginning, our height is going to be 6 meters off the ground, right? We're at the very top, it's diameter 6. So at time 0, we are 6 units or 6 meters off the ground. Now, we rotate. Now, if we just take a kind of a snapshot at these easy points to get, right? If we have a period of 20 seconds, 20 divided by 4 is going to give me 5. So each one of these little snapshots is going to be 5 seconds long. So basically down here I can go 5, 10, 15, 20, and maybe just sort of label them if you can. 5, 10, 15, 20. So at 0 seconds, I was at 6 meters. Now I rotate for 5 seconds, and now I've gone, and what am I? Oh, I'm 3 meters off the ground. So we can go ahead and label this as 3. So at 5 seconds, we're down here. Another 5 seconds passes, and now I'm basically at ground level. So now I'm at 10 seconds, I'm at 0 meters. Okay, and then I rotate again, and I'm back at 3 meters off the ground. And then I rotate another 5 seconds and I'm back up at the top. There it is. So get a smooth curve through there if you can. Now they wanted 2 cycles, so I'm going to sort of be corny here and do it like that. And I'm just going to label this point here as, let's see, 40 seconds, right? 2 cycles and 6 meters. And we can label this as 30 seconds. This is 25. And just kind of extend that 40, 35. And we can even put the dots, right? It's just going to repeat that same pattern. So there you have it. So there's 2 cycles, and it looks a lot like cosine. So that's what it says right in part B is, can you derive an equation starting from the top? Now, deriving an equation is one of the hardest things that we probably do with you guys because you have an option. You can use cosine or you can use sine. And the question is always, well, which one do I use? Which one do I always use? And unfortunately, there is no easy answer to that because it depends on the shape that you have. The answer is you can use either one that you like. So you can use sine and do an equation, or you can use cosine. I'd recommend use the one that it looks like. So this already looks like cosine, right? Cosine starts up here and has that shape like that. Sine looks like this. So the first one that I drew was sine. This one here, that's cosine, right? It's been shifted. This one's been shifted up. So we just got to figure out all those details. So like what's the amplitude? what's the B value? Is there a vertical shift and is there a horizontal shift? So the easiest thing to do right off the hop is the amplitude. Now remember, the amplitude is defined as the distance from the center of the function to the peak or bottom. Okay, so we can see that we're between 0 and 6, so the amplitude has to be 3. We already know the B value is 20, and now it doesn't look like there's a horizontal shift. Those are the hardest to spot, right? But cosine starts here at 1, okay, and this one here is still starting there at the very, very top. So there is going to be no horizontal shift, so none, but there is going to be a vertical shift. Right? Now, if we multiplied our cosine by 3, then we'd be between 3 and -3. Kind of a crappy sketch. There we go. Right? So there would be with an amplitude of 3. Now, everything's been shifted up. Okay? So to get this bottom over here to 0, I need to shift up 3 units. So I have a vertical shift of 3. So now my function looks like this. It's 3 times cos. We don't have a horizontal shift, so we can just write 20 times x and then plus 3. And there you have it. That's quite tricky. Now, do they always have that question on the exam? The answer is no. Sometimes they do, sometimes they don't. Part C says at what height will the point be after 12 seconds? Now, notice how they gave us one that's a little tricky to estimate, right? If they gave us 0, 5, 10, 15, 20, any multiple of that, we'd be able to estimate it. But luckily, we have our equation now, so we can just say, well, x is equal to 12, and we can pop it in here and see, what we get. I don't know if I have my calculator here. Just give me a moment. See if I can get it over here on the other screen. Yeah. You are going to need your calculator. Oh, you know what? I think I made a mistake here. The mistake being that I don't know that B is 20. Right? B is not 20. The period is 20. So that's a big boo-boo. The period is 20. In my equation, I need to have my B value. So, aha. I don't know if anybody caught that. Okay, but let's go ahead and figure out the B value. So remember that B is 2 pi over the period. So 2 pi divided by 20, well, divide by 2, and that gives us pi over 10. So yikes, that's a bit of a boo-boo. Not enough coffee? Too much coffee? I don't know. Now, this is going to make maybe part C a little bit easier. We might get an exact value. Now, on the exam, if it was no calculator, they would pick something that would give you an exact value. This time, we don't really know until we just do it. So I'm going to plug in 12 for x. I wrote it as 12 over 1. Don't let that trip you up. I have fractions, so I just automatically do that. So I can cross-reduce here. I can divide them both by 2. So I'm basically going to get y equals 3 cos. Now, when I divide, let's see, I'm going to get 6 over 5. Yeah. And I get 6 pi over 5, and I can't reduce that anymore. Now, you can check using coterminal angles, but we don't do anything divided by 5, so it's clearly not an exact value. So you will go to your calculator at this point and plug it in. And I think I've gone ahead and I've done the work already. And I got 0.57 meters. Now, you can always sort of spot check for accuracy. So like at 10 seconds, we're at 0. Right? By the time we get to 15 seconds, we're back at 3. So 2 seconds later, you could work out roughly how much you rise every second, but that seems pretty reasonable, right? At 2.5 seconds, I'd expect to be at about 1.5. So yeah, a second later, yeah, it's probably good. Okay. What's the last one here? Because it's getting a little long. D, when will the point first reach a height of 5 meters? Now this is the reverse question. So 5 meters is the height, and that's what y is. So in part D, they're actually asking us to go plug in, substitute in for y. So part D means we're going 5. That's a D, by the way. So you're going 5 equals 3 cos pi over 10x plus 3. Now, you'll want to watch this one because this one's bound to cause some issues. So first of all, subtract 3 from both sides. So now you're here. Now that you have that all written out, you can divide by 3. So you get 2/3 equals cos pi over 10 times x. Now, people lose their minds at this point. So what do we do? Well, in order to solve, think back to when you're at something like this, right? Like when you're doing these kinds of questions, right? How do you solve for theta? Well, you go inverse cos of whatever you have over here, and that equals whatever is the argument. Okay, so same thing here. We're going to go the argument, which is pi over 10 times x, equals inverse cos of 2 over 3. Now, if this was an exact value, which it isn't, you'd be able to go grab an exact value. In this case, you'd have to go to your calculator. Make sure that you're in radians. I'm going to quickly grab mine because I don't have that intermediate step. So we're going to go inverse cos of 2/3, and that gave me 0.84. So 0. Now I will keep 4 decimals till I get to the end. So 1, 0, and that's equal to pi over 10 times x. Now, to finally solve for x, multiply both sides by 10 over pi, right? Just the reciprocal. That's an easy trick. And now I'm going to take that answer and multiply it by pi divided by 10. And I get 0.264 seconds. There you have it. And yeah. Looks great. Question number 2. Another kind of nice light question here. So physics 1, we got a weight on a spring. So let's go ahead and just draw a little sketch. We got a weight. I don't know, it's on a spring thingy. There's my weight. Yay! Now, it's released from a height of 80 centimeters above the floor. So let's call this 80. And it drops to a height of about 40, and then it rebounds back to 80. So when we get to this halfway point, it rebounds back up. A timer started when the weight is released at 80 centimeters, and it reads 0.4 seconds when it reaches the bottom. So that means that to get from here to there, that took 0.4 seconds. And then on the way back up, another 0.4 seconds. Which means that in total, to get from where it started down here and then back to where it was, it takes 0.8 seconds total, start to finish. Now that's important because that would be one full cycle. One full cycle would be starting and then getting back there. Okay, now we know that that would be our period. So our period is 0.8 seconds. Now, I don't even know what the question is, and I figured that out. So it says draw a sketch of the situation. So this is not the sketch they're looking for. What they're looking for is the actual, sinusoidal equation kind of looking sketch. Although it'd be funny if you drew this. So let's see. Again, this is going to be height. So don't forget to label it in these real world questions. And this is going to be time in seconds. Now, I would maybe, because it's a sketch, just kind of do the axis as it comes on the x-axis here. So we start at 80. So we can just say, all right, there's 80. And we'll kind of go down about halfway, and we'll say there's 40, and there you have it. All right. So we are right here at 80 when we start at 0 seconds. Now, when we get down to 40, that's after 0.4 seconds. So depending on how you want this to look, we can go 0.4, and we're down here. And then when we kind of go and try to get roughly the same distance just so it looks nice, we're back up at 80. Now, I think we can agree it's easy to see that after 0.2 seconds, we would be at 60. Right? So we can go ahead and we can kind of do that extra little point here, 0.2, and that would be 60 right here. And then on the way up right here at 0.6, we're going to be back there. So there is one full cycle of this thing. And in the perfect world, it would keep doing that and it would look the same, but it would lose momentum. So after a while, it would get smaller and smaller. Anyways, we only need one full cycle to get that initial situation. We have our period, we did our sketch, and now they want for us to determine the equation. Again, that's the tricky thing, right? So whenever possible, try to use whichever sinusoidal equation it looks the most like. So this is not a sine curve. This looks very much like the cosine curve, right? Remember, the cosine curve looks like this. Obviously, it's been shifted up, okay? But you can really clearly see the difference, right? Between a sine curve, which looks kind of like this S, and this one, which looks more like a U, okay? So I'm definitely going to use cosine. And you might be asking, well, does it really matter which one you use? And yes, it does. If you use sine, you're going to have to do a horizontal shift in order to get it to line up properly. So I do recommend using cos. That's the one that'll make you the happiest because it'll be the least amount of work. Now we have A, B. Now we technically have A, B, C, D. Just remember, I've been calling D the vertical shift and C is the horizontal shift, but those are the letters we use. Now, we can easily get the amplitude. That's always really easy to get. Right? So from the center line, which would be right here at 60, how high up is it to the peak? Well, that's 20. So we got that. We have the period. We can easily find B by going 2 pi over period. So 2 pi divided by 0.8. Yeah, it takes a bit of, finagling. 0.8 is 4 out of 5. Okay, so I'm just going to go 2 pi. This is 4 out of 5, so do the reciprocal. So multiply it by 5 out of 4. So what the heck are we going to get? You can cross reduce. That's 1. That's 2. So you get 5 pi over 2 for B. Wonder bar. And we don't have a horizontal shift if we use cos, right? Because cos starts right here, and we start right there. So we're going to have 0 or none. However you want to see it. I don't know if that says none, but whatever. And now the vertical shift. So we have shifted. Normally we're at 1 and negative 1, right? Now apply your amplitude. So if you had an amplitude of 20, you would be at 20 and negative 20. We need to shift the bottom of it, which is at negative 20, all the way up to 40. That's the lowest we get. So what do we need to add to get up there to 40? So looks like we would have to add 60, right? So negative 20 plus 60 would give me the 40. So there you have it. Now you can write your equation. It's y equals 20 cos. Now we don't have a horizontal shift, so we can just write 5 pi over 2 times x plus 60, and you have your equation right there, handy dandy. What will be the spring's height after 3 seconds? So you could maybe, because the interval is 0.2, right? And 0.2 divides 3 evenly, you could easily figure out where you are on the curve. And you might do that, right? Like, for example, if you double it, so at 0.8, you double it again, you would still be at the same height, and that's 1.6 seconds. If you go another 0.8, that would bring you to 2.4. So you're still at the same point. Okay. You know what I mean? Like it does this, that's 0.8 seconds. It does this, that's 1.6. It does this, that's 2.4. So now start back at here, and then you could go 2.6, 2.8, 3 seconds. So what height are we at? We'd be at 60. That's an easy way to do C. Your other option is you could plug in an x value of 3 into here and solve it. That would be your other option. I'm not going to do that because this one worked out just handy dandy. Hunky dory. Okay, last one here. This one is about as tricky as they're ever going to come. It's totally doable, but it is about as hard as it's going to get. Okay, so I'm going to leave the last example. We don't need that many examples. This will be enough. So it's another Ferris wheel question, and they do like those ones. So people ride in these capsules, and the wheel has a diameter of 150. Now, I do recommend that you draw yourself a nice little sketch here. I'm just going to switch over here for a moment. So a nice little sketch. I think I got some room over here of the actual physical situation here. So we got this Ferris wheel, right? So I'm going to kind of go like this. And it is a diameter of 150. So that means the radius is half of that, or 75. Okay, so I'm just going to kind of go like this, and go 75. All right. Now, it says it completes 1 revolution in approximately 32 minutes. So that means if I start down here at the bottom, and I'll switch colors, if I start down here, after 32 minutes, I've done a full cycle. So, that would be the period, right? The period is 32 minutes. We can go find the B value later. We'll just go do it down here so we don't forget. Let's just do it right now. Why don't we? So it's 2 pi divided by the period. Divide them both by 2, and you're going to get that the B value is pi over 16. So that'll be handy later. What else have we got? It reaches a height of 165 meters. What? But the diameter of the thing is 150. So when I'm up here, I'm at 165 meters above the ground. So that must mean that this thing is obviously suspended off the ground 15 meters, right? So if from here to here is 150, right, then I need to shift it up 15 meters. And that kind of makes sense if you've ever seen a Ferris wheel, right? Like it would have a stand and there would be like a platform to bring you up. Right? So we're 50 meters off the ground, and when we get to the height, we're to the top, we're now at 165. So that'll make sense. Wonderful. By the way, what would that be? Like, what would that be in as far as a sinusoidal function goes? This would have to be some kind of a vertical shift, right? So the vertical shift, or the D value, is 15. We know the B value. We can easily find the amplitude soon enough. Right? Like the amplitude is the midpoint. So how high is it from here to here? Well, that's just the radius. So the amplitude is 75. All right. So I think I basically have almost everything. Now for part A, it says determine a function that models the height, h meters, of a capsule at any time t. So if they tell you what variables to use, you have to use those variables unless you want to lose some marks. So you're going to say h of t equals, now we might want to get maybe a sketch. I believe right here it says, like, can you sketch it? Now we're not going to be using graphing technology, right? We're going to use just what we know. So let's get a sketch. So right off the hop, when you sketch this thing, you're going to be, I'm not very happy with that's not very straight. I'm going to try one more time. It's probably going to be worse, but actually that's way better. Okay, so this is time. This is height in meters, and I want to go to a different there. So right off the hop, you're at 15 meters above the ground. Okay. Now, again, we can chunk this up, right? And we can do every, we'll check in right here, and we'll check in right here, and right here, and right here. So we're splitting that circle up into 4. 32 divided by 4, that gives us 8, right? 8, 6, yeah. So 8 minutes later, so we're going to do every 8 minutes, so you might as well just do that on your x-axis. And we know that once we get to 32 minutes, we'll be back on the ground, so we can do that step. So after 8 minutes, you're now here. So where are we on our diagram? Well, we are at 75 meters in the wheel, plus the 15. That would be at 90, okay? So again, it's just a sketch. So 90 is sort of our midpoint. So I'm just going to label this as 90. And there we are. And once we get to 16, we are at our maximum height of 165. So 16 minutes, 165. Then we're going to rotate down and we're back to 90 off the ground. And then we're back to where we started. So make it look sinusoidal. I can try maybe one more time. It's a little tricky. Still getting the hang of this writing pad. There. Now, if it doesn't look quite symmetrical, it's because obviously I was doing everything by hand. But there's the sketch. Now, we are looking for the equation, right? So we know the amplitude is 75. Big question is it sine or cos? This is a cos graph, right? But what's happened to it? So normally our cos graph would look like this, and this would be 1 and -1. Now, if we multiply by our amplitude of 75, then we'd have 75 and -75. But the shape still doesn't match. Well, if you do a flip over the x-axis and look like that, now we have the right shape. So we need to go -75 here, and we know it's cos. I can see that based on this point here still being on that axis, there is no horizontal shift. That's also the C term, so there's none. If you use cos, if you use sine, good luck to you. It's going to be harder, so don't use sine. We know our B value is pi over 16. Now, remember, they're using t, not x. We just need to figure out the vertical shift. So originally I said the vertical shift is 15 meters, but that's not going to cut it, because here we are, right, with our amplitude applied, and if I shift it up 15 meters, I'm not going to be over here yet, right? I'm going to be at like negative 50. So I need to get to 15. I'm starting on negative 75. So what do I need to add to it so that I get, 15? Well, you can solve this equation and it looks like you're going to get 90, right? So if you add 90, you're going to get to 15. So that's going to be the shift vertical that we need to add is 90, okay? Different from the picture, but it makes sense, right? So when we take this negative 75, we add 90 to it. Now we're at 15. All the other points will follow and it's going to be beautiful. So there it is. That's the last one I'm going to do for you. That's as hard as they're going to get on the exam, I promise you. That might even be slightly harder, but not too far off, okay? We're going to skip this one. And this one, oh my God. Here we go. So exercise 6.7 in your homework book, try it out. And definitely pick up the exams I've been giving you and try out all the trig questions on the exams, because those are going to be the best estimate of how hard it's going to be. Thanks for joining me, and we'll see you next time. Bye-bye.